Okay, so yesterday we finished our lesson, but we didn't have enough time to practice. So what I'd like to do is go over some of the questions we started and then have you guys finish it up. So let's see, yesterday we did this question and this one. Just review. This is page 19 in our workbook. The workbook is the skinny book. Determine the unknown interior angle measures in each triangle. Every triangle we know is 180 degrees total for the angles. Well, 105 and 135. 105 plus 35 plus measure of angle B should equal 180. Well, this is 140. I'm going to write it all out. You don't have to write it all out. You just have to be able to think it all out. If I subtract 140 from both sides of measure of angle B, or ABC, equals 40 degrees. That's what we did yesterday. So this one here is 40 degrees. And then he did this one as well before we left. So I'd like you to finish up these guys, or at least do 2 more today. Then we turn the page. You can hit pause while you do those. Oh, here's some more on this side. I'd like you to do some of the exterior angles. We didn't actually practice one, but let's do it now. For an exterior angle, if I know this is, I want to know FJK. I want to know this angle and FKJ in this angle. This is page 20 in our workbook. Well, I know this is 162. I know the total is 180. That means 180 minus 162 is 18. So FKJ is 18 degrees. We got 101 and 18. 101 plus 18 is 119. Subtract it from 180. That's 61 degrees for that guy. Okay, so basically what I'm doing here is I'm saying, if you see an exterior angle, can you figure out the interior? If I give you 2 interiors, can you figure out the third interior? Which I think you should be able to do. So do 2 or 3 of these guys. Here, we said draw all possible angles from vertex A. This is page 21. Okay, we went like this. We have a hexagon. We went like this. We could draw 3 diagonals. If we have a quadrilateral, we can go like that. All of them have to be from A. You can't go from any other vertex. And I can't go here because that's not a diagonal. That's actually a side of the polygon. Then write the number of triangles formed. Well, here's 2 triangles. 1, 2, 3, 4. 4 triangles. 2 triangles. 1, 2, 3, 4, 5. 5 triangles. You do those 2. Now you can do these 2. Here it says use the triangles formed by diagonals to calculate the sum of the interior angle measures of each polygon. Draw all the diagonals that connect to vertex A. Well, there's only one diagonal that connects to vertex A. The sum is 180 plus 180 is 360 degrees. Draw all the diagonals that connect to vertex E. This is a pentagon, so I got 2, 180, 180, and 180. That's 180 times 3, 540 degrees. So do a couple of these guys from page 22. Here, if I just tell you how many sides there are, 8 sides, 9 sides, 16, 25, 20, whatever it is, can you tell me how many? Calculate the sum, that means sum is total, of all the interior angle measures of the polygon. So Do at least 3. Find out the total number of angles, total number of degrees. Remember, the answers to the odds, I think, are in the back of your book. So you can check your own answers. You can check with each other. I encourage you to check with each other. Hit pause between each section, all right? Here, the sum of the measures of the interior angles of each polygon is given. Determine the number of sides of the polygon. Okay. If you know it's 1080, you could go to your table. So no, 1080, that's got to be an 8-sided polygon. All right, are you looking at, yeah, that's 180, 1080. So I'm going to say 8-sided. Also known as an octagon. OCT, octo? OCTA, OCTO. Look it up. Tell me which one it is. I think it's OCT. I'm rolling with it. I'm busy. All right, okay, if you don't have it on the table like this one, what can you do? Hit pause and see if you can figure out what to do before I answer it. I know it has to be a multiple of 180. So, grab a trusty dusty calculator. Take 6840 divided by 180. That tells me there are 38 triangles. Well, we know that 38 triangles has 2 extra sides, so this is a 40-sided polygon. Did you get that? For here, extend each side of the polygon to create one exterior angle at each vertex. All right. Extend each side of the polygon, each side, to create one exterior angle at each vertex. Oh, okay, they just want us to go like this. I mean, that's pretty. Do it as a pinwheel. You could go like this. You don't have to. Just as long as we have one exterior angle on each set, on each corner, each vertex, we're good. That's all you got to do. And this is the last part of what we're going to be learning from this topic. Topic 2, justifying angular relationships. That's our title. Calculate the sum of the measures of the exterior angles of each polygon. Wait a second. The sum means the total of the exterior angles. Outside angles. How many degrees are outside of a pentagon? How many are outside of a hexagon? How many are outside of a triangle? Nonagon, that's, nona means 9. 20gon, oh, hex means 6. Penta, pent means 5. So, how many degrees are on the outside of each of these? If you don't know, talk to a neighbor before you get the answer. All of them are 360. And that's the end. We're not going to do any more from this topic. So what you have instead is you're going to have an activity. If there are at least 5 of you, I'd like you to break up into 2 teams. If there's 4 of you, 2 teams, this is what you're going to have. You're going to have questions here. For example, this one, 120 degrees and A. Can you see that? On the bright pink one. Well, this is 60 degrees. You're going to cut each one of these triangles out. This A represents 60. It's going to get taped up to this 60 right here. Those 2 pieces will meet right here. Bam, you're going to have this triangle going under it. All right, so this 60 will get taped right here. You don't have to use a big piece of tape, just a little piece right there, just to hold it. Basically, here's an answer, here's an answer, here's a question. That one looks a little bit more difficult and hard to read. 64 degrees, 37 degrees, well, you can total it up, find out how many go there. Then you gotta find the, I think it looks like an R. here, 133 degrees, and y, well, what type of relationship is that? Cut it out, match it up. Its partner might be on the orange one, or it might be on the blue one. So you're gonna have to cut out all of these. Ideally, you got 2 groups of 3. If there's more than 6 students on Tuesday, make 2 groups, break it up evenly, cut them all out, and put the pieces together. This will be your activity. All right, if you have any questions, sorry. I'm hoping you can answer each other's questions. That's the goal. All righty, guys, take it easy. See you Wednesday.